Okay, in the third of these Christmas homework revision videos, we're going to look at some SUVAT questions. Okay, so those are the 4 SUVAT questions that you need to have memorized. If you cannot remember these, you need to sit and write them out 20, 100 times, whatever it takes. You've got to memorize these 4 equations. Okay, they're vitally important. And it's all about stating your initial things. Remember, all of these questions are about constant acceleration. Okay, so we can use each of these 4 equations whenever acceleration is constant. If acceleration changes, you've then got to look at the motion in sections. Right, let's look at the first question. Okay, so in the first question, we've got an aircraft taking off. Okay, it goes along a straight runway, which is A to B of length 1.2 kilometers. So there's your first problem. 1.2 kilometers. We need, when we do SUVAT questions, it's meters, seconds. Okay, meters and seconds we need. Right. Okay, so that's 1,200 kilometers. 1,200 meters, sorry. The aircraft moves from A with an initial speed of 2 meters per second. Okay, so first thing I always do is I'll write, switch to pen, write S equals, okay, I'll write U equals, V equals, A equals, and T equals. Okay, so I can then use those to help me work out which equation I'm going to use. Okay, so in this first one, so what do we know? The aircraft moves from A with an initial speed of 2 meters per second, so it's U is 2. It moves with a constant acceleration, good, I can use this the equations of motion, and 20 seconds later it leaves the runway at C. Okay, now you're probably thinking that this is going to go A, B, C. It's not. C is going to be in between A and B. And it leaves the runway with a speed of 74. And we want to find the acceleration of the aircraft in part A. So I want to find A. So I'm going to call that A. I'm going to underline that. That's what I'm going to find. I know it leaves the runway at 74. So its final speed is 74. Do I know the distance? No. I don't know the distance. Okay, I know nothing about that. And I know that it took 20 seconds for it to take off, so the time is 20. Okay, so what do we know? We need to look at these things now. I don't know S. Okay, so you need to think back to the first slide I showed. Which equation can we use? I want to find A. I know U. I know V. I know T. I want to know A. So I want something that's got V, U, A, and T in it. So you're going to use V equals U plus A T. Okay, sub in those values. So, right, all of this is going in one direction, so it's accelerating, initial speed, everything's going all to the left or all to the right, depending on which way you imagine it in your head. The initial speed was 2. The acceleration, I don't know, so that's A, and I'm multiplying that by the time, which was, sorry, not T, the time was 20. Okay, so I got 74, take away 2, equals 20A. So that means A equals 72 divided by 20, which gets us 3.6 meters per second squared. There we go, part A done, 2 marks. Right, part B, distance. Okay, so see if I can squeeze this in over here. Right. So now, when we're looking at this, okay, when we're going from A to B, so I draw a really quick diagram. So at A, up here, so that's A. Okay, B is over here, where the end of the runway is. And then C is where it took off, which is here. It travels there, okay, so it takes off at this point here at C. The distance from there to there is what we know. We know that's 1,200 meters. And the question is asking us, what's the distance from B to C? I don't like the way they've worded that, because you'd think it was B over here, and then C there. But it's not, it's C, B. So they want us to know that distance. So we're going to work out, well, what distance does it travel going from A till it took off when it was traveling at 74 meters per second? And then we'll have to take that away. So that's the key to this question. That's why it's worth 4 marks and not just 2. Right, so I'm going to work out the distance from A to C. So for A to C, right, the same initial conditions as I have written above here. So I've got those, so I'm going to use those. But this time, I'm going to want to work out S. Okay, and I know everything else. Okay, so I'm actually going to try and do this without this. So in case I've got this wrong, okay, I'm going to look, is there an equation I can use that doesn't have acceleration in it, which would help me get S? And there is. I can use S equals U plus V all divided by 2 multiplied by the time. Okay, this way, in case I've made a mistake in A, I'm not compounding that problem. Right, so we've got 2 plus 74, dividing that by 2, and multiplying by 20. So the distance travelled in lifting off the ground, if you do the maths there, is 760 metres. But that's not our answer, because that's the distance from A to C. Okay, so that's AC. We need to work out for B to C. So B to C is 1,200. Take away 760, which gives you 440 metres. Don't break it 4. Done. Question 1 done. Right. In the second question, we've got a stone thrown vertically upwards. So we need to be really careful in this question. Okay, because you've got, first thing, let's get our diagram right. We've got a stone which is thrown vertically upwards. Okay, but gravity's working that way. So I'm going to have to be careful because the acceleration is going to be 9.8 that direction. So I'm going to have issues. I know that the height of this cliff, or whatever it is h. First thing we got to do is figure that out. Right, okay, so for part A, SUVAT it. So S equals U equals V equals A equals and T equals. So do I know S? Well, I want to find out what the height of the cliff is. So my height, or S, distance travelled, is going to be the height, because I'm going to find out what it was at the bottom. So initially, we know it's projected upwards. Upwards is going to be positive for me. That's going to be 16. Its final velocity, I'm not interested in. Its acceleration is going to be minus 9.8. It's minus because I've said upwards is positive. Okay? And the time it takes 4 seconds to hit the ground. So my time is 4. Okay? Don't fall into the trap of thinking that in this question that the final velocity is 0. It's hit the ground at that point. We're looking at that instant just as it's about to impact the ground. Right, so what do we know? We need to figure out which equation we're going to use now. So S, remember, is what I want to work out. So I want to find S. So I need an equation with S in it, U in it, A in it, and T in it. So I want one that doesn't have V. And there's only one option. You have to use S equals UT plus half AT squared. Okay, so now it's just a matter of substituting and solving the equation. So S is h in this question, so I've got initial velocity 16 times 4 plus a half times minus 9.8 times t squared, so that's 4 squared. So you should get 64, take away 78.4. So my height is minus 14.4 meters. Now, you can't have a height that's minus distance. Okay, mine's minus because my initial point is up here. So that is my 0 distance. So anything below this down here is going to be negative. So I've got minus. So when it says what's the value of h, I now need to write height equals 14.4 meters. There you go, there's my final answer. Okay, for the second part, so for part B, I'm going to squeeze it in over here. Okay, so part B, right, we're looking at the speed of the stone as it hits the ground. Okay, so that's just that instant, just as it starts to impact. Okay, so again, I'm going to try and do this without using height in case I've got that wrong. I haven't spelled height right. Okay, so I'm going to avoid using S. Okay, so S we don't know. Initial, U is going to be 16. V is what I want to work out this time. Okay, so V is what I want. That's supposed to be an equal sign. A, the acceleration, will be minus 9.8, and the time is going to be 4 seconds. Right, so what have we got this time? Let's see. I want something that doesn't have S in it. Oh, that leaves us one option really. I'm going to have to use V equals U plus AT. Okay, so substitute the values in then that we know. I want to find V, so that's called V. That's 16 plus, well, acceleration is minus 9.8, and the times, what, T, so undo that, is 4. That's a bit messy. So you get minus, final velocity, it's minus 23.2 meters per second. Right, now, the question asks for the speed at which it hits the ground. Okay, so remember, that's a velocity, so the speed. Okay, make sure you show the examiner, you know the difference between the two things. Speed it hits the ground. Speed hits the ground, and my untidy handwriting is 23.2 meters per second. Okay, done. Okay, right, slightly trickier question this one. Okay, so this time I'm going to do a really basic. So I've got 3 points, P, Q, and R. Okay, so you get 3 posts fixed in that order. From P to Q is 45 meters, Q to R is 120. Car is moving along the road with constant acceleration, so the acceleration is the same all the way through this. So I could look at this motion from here to here, I could look at it from here to here, or I could look at it from there to there. The speed of the car as it passes P is U. Okay, so there it's U meters per second. That's not very good, minus 1. Okay. The car passes Q 2 seconds later, so that's after 2 seconds it's there. It's supposed to be an S. And then passes R 4 seconds after going through Q. So that is 6 seconds in total there. Okay, I'm going to look at the whole motion for this. Okay, because the question then goes on to ask us, right, find U and find A. Right, there's a lot of things we don't seem to know in this question. We're going to have to work out what U is. We know the distance there is 45. We know the distance from there to there, but other than that it takes 2 seconds to get to Q, and the distance to Q and from Q to R, I don't know much about this position. So I'm going to look at the motion from P to Q, and then from P to R. Okay, because that gives me a few things that are the same. And this is actually a simultaneous equation question. So let's look at P to Q first. So P to Q. Alright, so if I look at P to Q, the distance is 45 meters. Right, U equals U. Final velocity, I don't have a clue what speed it's doing as it's going through Q. Its acceleration, we don't know, but its acceleration is the constant, so for the whole motion, so I know it's going to equal A. And I know that that time was 2 seconds to do that. Right, so here comes the tricky bit. We've got to figure out what we want. So I want something, basically, the giveaway in this is that you don't want V to be in it. We don't know anything about the velocity here or here, so I don't want to have this in it. And if you don't want V, you have to use S equals UT plus a half AT squared. Okay, so if I put the information in there, what do we know? We know that that's going to be 45 equals 2u plus a half times a times t squared. Well, t squared will be 4, and half of 4 is 2, so that's going to be 2a. Okay, I'm going to call that equation 1. Let's have a look at the motion from P all the way to R. Okay, now I'm going to go P all the way to R because I've got things in common then. I don't know, if I was to look at Q to R, I don't know what the initial speed is there. Okay, we have no idea what the speed is at Q. So if I look at P to R, I do know the initial conditions. Okay, I know the distance travelled this time is going to be 165. Okay, because it's from P all the way through to R. U is going to equal U. It's the same U as in the P to Q motion. V, we're not interested in. This time V would be the speed at R. I'm not interested in that. Acceleration will be the same. It's A. And the time, well, this time it takes a total of 6 seconds to get from P to R. So the key to this question is realising that. Again, I don't want V, so I have to use S equals UT plus half AT squared. Substitute in what we know, so that's 165 equals 6u and plus 18t. 6u plus 18t. Sorry, not t, it's a. So I'll do that. 18a. Right. Okay, now, so I'm going to call that equation 2. So I've got two equations, two unknowns. Okay, so using a bit of your C1, your GCSE knowledge, I am going to obviously tell the examiner what I'm about to do. I'm going to do equation 2, take away 3 times equation 1. Okay, so I'm going to use equation 2 as it's written there. I'm going to be a little bit lazy on it. Equation 1 times 3. So 145 times 3 is 135. So that's 135. And that equals 3 times 2u is 6u. And 3 times 2a is 6a. Right, and I'm going to be taking those things away. So that's going to leave me with 30 equals, the 6u's will cancel out. 18a take away 6a is 12a. That means a equals 2.5 meters per second squared. Done. So I haven't worked this out in the order they asked this in the question, but the examiner won't be bothered about that as long as it's right. And I'm going to sub that into 1. So we'll work at a squeeze. I'm going to squeeze this in just over here. I'm going to sub into equation 1. So I'm going to get 45 equals 2u plus 2 times 2.5. Not very good plus. Okay, and you should then get that 40 equals 2u, so the initial velocity is 20 meters per second. Question done. Last of the SUVAT questions, question 4. Okay, so in this one, let's get a little diagram right. So there's my little cliff, so it's a particle being projected upwards. I'm going to need to be careful with my signs. Okay, I always take up to be positive. So in this question, this is projected up with the speed of u meters per second. Acceleration is going to be that way. It's going to be gravity. Okay, we know the height of the cliff this time. It's 10 meters. Right, and we know that it hits the ground at t seconds. So it hits down here at capital T seconds with a speed of 17.5 meters per second, just as it hits the ground. Right, part A, we've got to find u. Okay, so let's do A. Right, SUVAT, what do we know? Right, now, my initial conditions up here. So this is where I'm starting. Up's positive, down's negative. This is 0. This is displacement 0. When I'm down here at the bottom, our displacement is going to be minus 10 because it's 10 meters below. So we've got minus 10. Initial speed is u. Final speed. Now the final speed, again, you think about it, this is projected up, so it's going to go up, then it's going to come down, so it's heading downwards, so its velocity is going to be negative, so that's minus. Alright, switch to pen. It's going to be minus 17.5. I have to squeeze acceleration in under here. Acceleration is going to be minus 9.8 because it's acting downwards, and the time is capital T. Now, part A wants me to work out u, so I want an equation that doesn't have t in it because I don't know t. Okay, so I want something that doesn't have t in it. Well, the only option not to have t means we have to use v squared equals u squared plus 2as. Okay, I want to work out what u is, and I know what v is, I know what a is, I know what s is. Okay, gonna have to be really careful with negatives here, there's a lot going on. Okay, so v squared, so I've got minus 17.5 squared equals u squared plus 2 times minus 9.8 times minus 10. So you're going to get u squared plus 196, two negatives make a positive, minus 17.5 squared will get us 306.25. So u squared equals 110.5, or 0.25, sorry. So that means that u equals 10.5. That's meters per second. Not quite enough room to squeeze the units in there. Right, we did take the square root there, so this technically could be positive or negative. Okay, but remember we were told it's projected vertically upwards, so we take the positive. Alright, part 1 done. Part 2. Alright, so in part 2, it's the same initial test. So I'm not going to write the initial conditions out. I'm not going to write these out again, but we now know what that is. Okay, again, can I avoid using that? I actually can't. I have to use it this time. Okay, so I know this. I want to work out time t. So I can use any one I want. Easiest one I think to use is v equals u plus a t. Okay, that's really important when you're doing these equations. Don't go straight into substitute values into an equation. Show the examiner which equation you're using. Okay, don't make them try and work out what it is you're using. Okay, say I'm using this equation by stating it. Right, all I've got to do now is substitute in the values. So v minus 17.5 equals initials 10.5, which is positive, and then it's minus 9.8 times, and it's a capital T. Right, so doing a bit of multiplication, rearranging, I get minus 28 equals minus 9.8 T. So T equals 2 decimal places, 2.86 seconds.